Okay, today we're going to talk about proportions in triangles. We're going to have you learn the side splitter theorem, and this is also called the triangle proportionality theorem, as well as the triangle angle bisector theorem. And we'll also learn some converses of these as well. So let's first talk about the side splitter theorem, and this is also known as the triangle proportionality theorem. And this says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So here we have two parallel lines. We'll call this triangle ABC, and this will be D and E. So we have AC is parallel to DE, and it is going to divide the sides of AB and CB equally, or proportionally. Okay, so this, if you think about what we've already done with the mid-segment theorem for triangles, as well as the mid-segment theorem for trapezoids. This is kind of the general theorem of that for triangles. Okay, so what this says is if we divide it up, then we have this side is parallel to this side, and these other two sides are divided up proportionally. Let's see what that means for us. So let's say that segment DB was 6 centimeters long. And let's say that segment AD was 2 centimeters long. And let's say that segment CE was 1.5 centimeters long. Then we should be able to figure out how long segment EB is. Okay? We know nothing else about this triangle. So we should be able to say that 2 divided by 2 divided by 6 is equal to 1.5 divided by x, because it divides these sides proportionally. So that would give us 2x equals 6 times 1.5. So 2x should equal 9, and x should equal 9/2 centimeters. So 9/2 is 4.5, so 4.5 centimeters for this length. Okay, so that's how it's going to work. Let's do some more work with this. So let's set up a problem for ourselves here again. Okay, so here's our next problem, and we want to know what is the length of x. So we know that 8 divided by 3 should equal 6 divided by x. And so you see how we're setting this up. The segments are proportional to each other. So this segment's proportional to this segment. I could have also set it up as 3 over 8 equals x over 6. Okay, that's another way I could have set it up. There's lots of ways I could have set it up using the proportionality properties that we studied at the beginning of the unit. But I'm just going to set it up this way because, I don't know, it kind of goes with the picture a little bit. So that will give us cross-multiplying 8x equals 18. Dividing by 8, I get x equals 18/8, and I will reduce that to 9/4. Okay, so this is roughly, let's see, 2 1/4. Not even roughly, it is 2 1/4 centimeters. Okay, sorry for the dog barking in the background, but that's what you get when you record at home sometimes. So, next thing we want to talk about is the corollary to the side splitter theorem. And this says if 3 parallel lines intersect 2 transversals, the segments intercepted on the transversals are proportional. So, this segment A divided by B should equal C divided by D. Okay? And there was another theorem, or something like that we did earlier in the year that looked a lot like this. But this is the corollary to the side splitter theorem, and it allows us to find lengths when we don't know much else about the properties of the lines. So we'd have no idea about these angles. All we know is that these three lines are parallel and these just intersect randomly. Okay, but it allows us to, without a lot of trigonometry or anything else involved, find lengths of these segments. So let's work this problem out. So we know that 3 divided by 7 should equal c divided by 10. So 7c should equal 30, and c c will equal 30/7, which is 4 2/7 centimeters. Okay? Now let's talk about the triangle angle bisector theorem. So we have a triangle, any triangle. This one happens to look like a right triangle, but we don't know that it is. And we have this bisector. It's an angle bisector for one of the angles, and it cuts angle A into two equal pieces. Okay? If we have an angle bisector, then this ray, that's the angle bisector, divides this opposite side here into two segments that are proportional to the other two sides of the triangle. So we're saying CD divided by DB is going to be equal to CA divided by BA. Okay? So this kind of follows because, you know, if AB or BA is really long, then obviously that's going to impact a lot of how this relationship works. So we're saying that not only does the angle bisector bisect this angle, but there's also a relationship between the side that it intersects and the sides that created this angle bisector. Okay, so they're all proportional. So CD divided by DB is going to equal CA divided by BA. Okay, the other way we could write this is DB divided by CD equals AB divided by CA. Okay, just so that you know that these two sides have to be divided somehow, right? And then whichever one of these two segments are on top, the side that's adjacent to it will also be on top. Okay, that's kind of how it works and how you can remember it. So here we go. Here we have this triangle, and we have our angle bisector, and we want to find this missing segment. Remember I said that if we're going to put one of these segments on top, right, like say 2.5 is going to go on top, then this side that's adjacent to it will also be on top of our proportions. So 2.5 divided by this x should equal 3 divided by 10, which leaves me with 3x equals 25. So x equals 25/3, which is 8 1/3. So x is going to be 8 1/3 centimeters. So what we've learned the side splitter theorem and its corollary. We've also learned the triangle angle bisector theorem, and this extends the proportionality concepts to angle bisectors of triangles. Okay, so we'll do a lot of practice problems with regard to this, but these should be pretty easy problems for everybody, and hopefully you can see how to set these proportions up. That's probably going to be the most difficult part, is learning the patterns for the proportions in the side splitter, its corollary, and the triangle angle bisector theorem. That's it for today.